Some parts of the equation are now better understood than they were in 1961. We know planets are common. We know that small, rocky planets exist. We know that water, carbon, and organic molecules are not unique to Earth. But the later parts of the equation remain almost completely unknown. We do not know the probability that life begins on a suitable planet. We do not know whether complex life is a likely result or a cosmic accident. We do not know whether intelligence tends to evolve, whether technology tends to follow intelligence, or how long a technological civilization usually survives. We have exactly one confirmed example for every one of those questions: Earth. That is not enough to build reliable statistics. It is like trying to understand every ocean on every planet by studying one cup of water. Still, the Drake equation is useful because it shows where the uncertainty lives. Suppose there are 100 billion stars in the Milky Way. Suppose only 1 in 10 has a planet with conditions that could remain suitable for life. That would still leave billions of potentially interesting worlds. But potentially suitable does not mean inhabited. A house can have electricity, water, and empty rooms without anyone living inside it. A planet can be rocky, temperate, and chemically rich without life ever beginning. This distinction matters because popular discussions often jump directly from planet in the habitable zone to second Earth. The habitable zone only describes the distance where liquid water might exist on a planet's surface under the right atmospheric conditions. It does not guarantee oceans. It does not guarantee a stable climate. It does not guarantee oxygen. And it certainly does not guarantee forests, animals, cities, or radio towers. Venus sits near the inner edge of our sun's habitable region, yet its surface is hot enough to melt lead. Mars lies near the outer region, but today it is cold, dry, and exposed to radiation. Habitability is not a label a planet earns once and keeps forever. It is a relationship between a star, a planet, an atmosphere, a magnetic field, geological activity, chemistry, time, and chance. Earth itself has not always been friendly to complex life. For much of its history, there were no animals, no plants on land, and almost no oxygen in the atmosphere. The planet went through asteroid impacts, massive volcanic events, global glaciations, and multiple mass extinctions. Life survived, but survival was never guaranteed. So the discovery of thousands of exoplanets did not solve the mystery, it sharpened it. We now know that the raw material for planetary systems is everywhere. What we do not know is how often a planet crosses the long distance from chemistry to biology, from biology to intelligence, and from intelligence to a civilization capable of making itself known. Planets are common, life may not be, and before we assume the galaxy should be filled with voices, we need to ask the most basic question of all. How difficult is it for life to begin?